Hello and welcome to Automating Networks with Python Network Automation. So in this short video, I will first walk you through my network design, then I'll come back to the codes, then I'll take you to the configurations done on my router. So first of all, I'll show you my design. This is my design and this is my control center. That's my local PC. It has connection to all network devices. That's how you do automation. First, you need an out-of-band network management so that configurations wouldn't conflict with connecting ports or usable ports on the in-band network. So I have redundant links connecting to this PC, which is my own PC. I've created a loopback interface connecting my PC to my physical network in GNS3. Now, I have core switch 1, core switch 2, access switch 1, access switch 2, and access switch 3. Now, taking into consideration the Cisco LAN design, this is a collapse core network. I'm building this network based on my previous video on network automation. So this two switches is going to act as the distribution layer. The core function of our network is being done on the FortiGate firewall, and I will show you. And as usual, access switches will provide connectivity for end devices. So back to our router. This is our router. It's a live FortiGate firewall. As you can see, I'll go to network interfaces. It will load very soon. Let me refresh the page. Okay, so it has refreshed. Currently, we have three ports available: one for management, one for one ISP, and then one as our internal network, all of which VLANs are being created. Now, before it loads, let me walk you through the Python. Right, so this is a Python script. I'm using Netmiko for the configuration for the core switches. So from Netmiko, we are importing the connect handler, which is a model in Netmiko. I'm importing get pass will prompt us for a password, and I'm importing time will measure the executing range for our script. Okay, so we have a dictionary. Okay, before that, we have a variable username which will accept an input of the username of the configured on the remote device. It also accepts the password, that's the get pass. And then we have a variable called that to_IP, call one under IP_IP address, which will take a variable of IP addresses for the respective dictionaries of values for a particular device. So we have the device type Cisco iOS, the IP address, the username, which is a variable, password, global delay factor. Will pause the script once it is able to connect to the device, because remember, we are pushing several lines of configuration to a switch or through virtual lines. And then also remember, it's being run in a virtual environment, so we take resources into consideration. Now, same applies to core switch 2. So we open the configuration file, which is here, and I wouldn't want to waste my time explaining this. As network engineers, we understand what all this means: VLAN, creating SVIs, and a whole lot, and DHCP protocol. So that's it. I'll walk you through from here. Like some seconds for you to take a glance through. That's good. So we have VLANs, we have SVIs, we have HSRP, we have trunk ports to carry VLAN traffic. Okay, so we assign a variable or devices. That's the first configuration for core switch 1. We will connect to that particular device in core switch 1, and then we show the running config by section. We get the only host name for that particular device, and then we print the output as a string connecting switch with host name over here. So core switch 1 will be printed, and then the output is equals to the connect handler, and then we send the configuration lines, and this is the configuration lines. This is text or string manipulation. So if we assign all the strings in core switch 1 to lines, same applies to core switch 2, not much of a difference. So we'll go on to the configuration for access switches. On access on Naplam is quite simple. So what Naplam will do You see, it also has JSON to format the output. We also have import, get pass. You have time to measure the execution, and also we have the network driver, which is very important. And as you can see, we have iOS for Cisco, and then we start the time taking an input for username, taking an input for password, taking an input for IP addresses. These are all security implementations, so that even if someone gets the script, the person wouldn't know the IP address used on our out-of-band management or network for management. Once again, so once we get the details right, we open a connection to that particular device, and then we will load the configuration, which is here. Quite a simple configuration. Once it's loaded, it will compare with the running configuration on the switch over here, and then it will print the difference. Before that, we will issue a condition that say, okay, we've assigned that results to a variable called diff. Once it's loaded, it should compare with the running config. If it's greater than 0, we should print committing the changes, and then we will commit the changes, and it's done. So if you were to repeat the configuration again, and then it will compare the differences, and if it's not greater than 0, it will print no changes required, as the variable we assign to the device disregard configuration, and then we will close the connection. We will print in the time that it took to execute as a variable end, and then we will print total execution time and minus that. Then we get our results. Lastly, what we're going to do is take a backup configuration of our configuration. So we are going to leverage on Netmiko once again, and we import threading. Threading is like it's multi-threading. It will perform several tasks simultaneously. Now, previously, all these scripts will perform tasks one after the other, particularly one for the core. The script for the core will execute the tasks one after the other. Good. So back on the backup, so this will execute show run. So this is a function config. So we have the net connect handler connecting to the switch, and it will type show run, and it will find a prompt, and then we will use indexing and slicing for strings to get the host name. So as you can see, we also have the date time now, as we imported from datetime, so that we can save the configuration per host name, the year, the month, and the day, as you can see on the other side over here. Right, so after that, we will print the backup of the host name successfully. These are string manipulations, and we open the device. So device.txt contains IP addresses for our devices, and then we will start an emphasis in these devices. We should connect to it, and then when we are done connecting, we should start a thread. A thread will combine all the tasks into one whole job, and then we will append it to a thread, and the target is the function that we specified here. So now the target is the config, that's the function, and then the argument is the switch inside, and then we append the threads to the empty threads we created over here. And for threads, we create a loop for it, so it will loop through the IP address, perform these tasks simultaneously, and then when you are done, we will get the time of execution and everything. So that's basically briefly using Python. I don't want to waste much time explaining everything to make the video boring. And back on the switch, I wanted to show you the VLANs. On the firewall, I wanted to show you the interfaces created. So as you can see, my devices are slowing down, but all the same it will work. Let me pause the video and continue when it comes back. Okay, so let me show you the configurations on my FortiGate firewall. So I will access my FortiGate firewall at this IP address. Remember, I said it's the out-of-band network management. So it has this IP address configured on the FortiGate firewall for management. So I'll log in to my FortiGate firewall. So I'll say later. So first of all, we are being presented with a dashboard to see what's going on. And as you can see, it's a virtual machine. So I'll go to network. That's where our focus is. So currently we have 3 interfaces configured on the router or the firewall. We have the LAN, on which we have 3 VLANs: VLAN 10, VLAN 20, VLAN 30. Now these VLANs are going to be created on the core switches as part of the configuration file, which is going to be executed by the Python script. So it will create these VLANs, name these VLANs, and then the second script, which is for the access switches, will assign these VLANs to individual ports. So access switch 1 will be configured on Ethernet 0/3 on VLAN 10. Access switch 2 will be configured on VLAN 20 for the host, and then switch 3 will be configured for VLAN 30 for the host. Now, what else do we have? I've set the DNS of in the script, the configuration file, to use the DNS of FortiGate firewall for simplicity, because at times if you try to change the DNS to that of the ISP, you might fail. Or in other cases, for example, if you are using Sophos firewall, the internal gateway for every network happens to be the DNS server. But in the case of FortiGate, I've tried it several times. Using their own DNS works better than using the DNS of the ISP or the internal network, right? So what do we have next? I also have static routes. So I have a static route which points to the internet, which directs all unknown traffic to the internet. Okay, so I also have firewall policies. So with the firewall policies, I also have firewall policies. So with the firewall policies, I also have VLAN 10, VLAN 20, VLAN 30, and the internal VLAN. Now these policies these are rules that allows these networks to connect to the Ethernet. So basically, routing, policing, and everything is done on the core layer, which we have the FortiGate firewall operating at this layer. So that's all for the core, or that's all for the firewall. So once we run the script will program the switches to come into an agreement with the rules on the firewall, so that the host PCs can ping the internet. Now in most cases, after some of the workstations will be able to ping, and others to take a bit of time before it can ping the internet. That's not the case here, and that doesn't mean that I tried it on my home system, it works so fine. The problem is that I'm running this video from my laptop, so at times there will be a bit of slagging, or it will slow down a bit because I'm running virtualization on my laptop, and at times the system tends to slow down a bit. So without wasting much time, that's all for the FortiGate firewall, and let's move on to the next section. So let's SSH to core switch 1. So the username on my core switch 1 is Storm. That's my nickname. 128.137.2. And when you SSH to your network device for the first time after configuring SSH, you'll be asked to accept the fingerprint, and of course we need to accept, and then we enter the password. So as you can see, I'm in core switch 1. Once again, show IP interface brief shows me the IP address of core switch 1. So exit. So now let's do same for core switch 2. We accept the fingerprint, and then we type in the password. So show IP interface brief, and that's the IP address for core switch 1. And mind you, I'm controlling or SSHing to the network devices from my PC. Okay, so as you can see, the user's name Storm, that's my PC. I can show you over here. That's my name over there. Right, so let's do for access switch 1. We accept the fingerprint, yes, and then we type in the show IP interface brief. That's the IP address for access switch 1. We move to switch 2 access, Yes, the password is storm. So show IP interface brief. That's the one we troubleshooted. So 5 exit, and the last one is access switch 3. Yes, password is storm. So show IP interface brief. So from access switch 3, let's ping my loopback interface on my PC, which I'm using to control these devices. .1, and as you can see, it can communicate my PC back here. So that means we are good to go. Good to go. Now, for the sake of this project, I will open up a new terminal from a USB drive where I've kept my configuration separately for this project. Okay, so let me open it. Open Windows Terminal. I have different suites for doing network automation. I have Ansible, I have Paramiko, I have Netmiko, and I also have Naplam. So I choose what I decide to use, not because that it's easy or something. It's not easy. I take time to develop the script, so none of them is easy. But then, for the purpose of this video, I can use any script to do it. So that's not the case. So now there will show me the over here. So that's it. So are you ready? Good. So first of all, to execute the script, which is a Python script, I already have Python installed. So let me show you Python. So I have the Python 3.95 on my local PC. So exit. So Python 3.py. So when I execute the script, first of all, it's going to ask for the username. That's the username configured on the network device. Now we have to enter the password. And now you see it's asking us for the IP address for the core first, or the core switch 1. So I will type in the IP address, which is 192.137.137.2. Good. And now I have to also enter the IP address of core switch 2 because the script has a dual, or it's multitasking. 168.137.3. And now, as you can see, configure switch with host name core switch 1. And the script might fail for the first time. That doesn't mean the script is not working. It's because I'm working from a virtual environment, and at times it will go through, at times it will fail. But then if it fails, we will run the script again. So we see the command has paused. It's because of the what I showed you. So just as I said, it will fail. It doesn't mean the script is not working. The script is. We have to run it again because of once again we type in the IP address 168.137.2, 192.168.137.3. So it will start executing the script. So you couldn't turn it to core switch 2. So let's try ping 192.168. There's nothing wrong with the script, I know for sure. It's just a matter of working in the virtual environment. So I can ping core switch 1. So once again, let's ping core switch 2. Yes. So let's run the script again, definitely to go through. So storm, password storm, IP address 192.168.137.2, 192.168. I'm not sure I entered the password right. I was typing too fast. I wouldn't be surprised if it fails. So once again, let's see what happens. Okay, the password is okay. So we are now configuring core switch 1. So let's hope the commands will go through. Yes, it has. So as you can see, the tons of configurations or the number of configurations being pushed to the switch. So you couldn't connect to core switch 2. Don't worry. We will run the scripts again. It will work just because you are working in a virtual environment. At times there are lapses, and then this thing also depends more on the architecture of your host PC. The architecture of your host PC running the virtualization platform. So my laptop is okay, but times it's not that okay when it comes to virtualization. 37.3. Trust me, it will go. I've tested the script several times, so it will go. I know what I'm saying. So let's configure core switch 1, and hopefully we'll move on to core switch 2. Okay, so let's see what happens. Okay, we're now moving on to core switch 2. Right, so we are done. That's all. So as you can see, I told you the script works fine. There is no problem with the script. So this is the time it took to execute the task. I mean, you can just imagine. So we'll convert that time to minutes to see how long it took. So let me scroll up. So it started from here. So where is it? Up there all the way down. So let's convert this to minutes to see something. So first of all, convert, say, seconds to minutes, and I'll copy this. So I'll put in the second. Oh, sorry, that's not fair. So let's take it 2 decimal places, 53.46, 53 point to a minute, but then it wasn't even close to a minute. It's 0.8.19 minutes, which is 53 seconds, right? I'm not sure it's even 53 seconds. No, that's milliseconds. So that's milliseconds. So I'll change it to millisecond, right? And I'll change it to second. So as you can see, that's millisecond. Yes. Okay. So we are done with the core switches. Now moving on to the access switches. So once again, Python. So let's test the connectivity. 192.137.3. Okay, we are good to go. So Python access.py. So Python access.py. Now let's verify from the access.py configuration. So that's it. We'll be connecting to these variables: IP address, username, password, and then we will load access.1.txt. So let's see access.1.txt. No, so this one is config rather. Why don't I name it to tst? So txt txt. And now we are going to connect to access switch 1. So Python access.py. So now let's verify from the configuration for access. So access1.txt. Okay, we are good to go. So let's run the script. So we key in our username, which is Tom, password is Tom, IP address of the remote device 192.168.137.4. Okay, so the configuration for access switch 1 is complete. So it printed out the differences and then it will commit the changes once the loaded configuration is greater than 0 as comparing to the one on the switch. So you can see the execution time very fast. So now we are moving to access switch 2. So Python access.py. One thing I want you to notice is that look, this is for core switch 1. It has placed this port E03 in VLAN 10. So now we are executing the script again for access switch 2 and the IP address 192.168.137.5. So it also print out the differences. Okay, so let's run the script again. Nothing is wrong with the script. Mostly it has to do with the virtualized environment. System 192.168.137.5. So through, sure it has. Notice something. It has placed E03 in access VLAN 20. So that's what I was talking about. So now the last switch, access switch 3. So that's it as we have. The configuration file is there, so it will just load it. That's the power of automation. Simple, simplicity, efficient, and everything. So I don't know why it went wrong. Let's execute the command. Okay, so now this is for access switch 3. Sorry, I'll input the name storm. So once again, there's nothing wrong with the script. The script works so well. Times my laptop has been up for a very long time, so that's why. So that should not be the case. You run the script again and it will work, don't worry. Okay, same thing. Says that it will work, don't worry. Okay, same thing. Says .py. Storm STORM. IP address is 192.168.137.6. So hopefully this time around everything will be fine. As you can see, it places it in VLAN 30. So let's try to execute for access switch 2 again, just to be sure that everything is fine. So again, we execute. So storm, the password is storm 137.5. I wouldn't be surprised if it fails again. I'm not sure the password I typed, but I'm sure. Yeah, so now we are good to go. So now back on our switches, you can see that the switches has been configured from the virtual lines. As you can see, that's the host, that's my control center's IP address, that's the loopback interface. Same applies here, and then core switch 2, same applies here, and then same applies here. So now let's check the VLANs from the access layer. So en show IP interface brief. So as you can see, same show VLAN brief. As you can see, we have 3 VLANs and only one has been assigned. So en so show VLAN brief. So as you can see, administration has been assigned to VLAN 20. The script did the magic, everything is fine. To VLAN brief. Now I move to the last part, which is the most important part, to test for connectivity with the internet. So back to my design. Here is it. Let's see if we can get an IP address. Console and console. And for this one, I'll delete it and add browse to a website just to see that everything is working fine. So I'll bring the web term to browser. Sorry. Okay, so I'll connect to interface 03, which is in VLAN 30. Change the configurations to accept DCP, and I'll click on save. Okay, so I'll minimize this one. Now back to PC 1. I'll type IP DCP. PC2 IP DCP, and trust me, we have an IP address. So as you can see, we have an IP address. Show IP. Show IP shows me that there's an IP address has been leased. So back on call switch 1, I can type show IP DAC release pool. Okay, so as you can see, current index is 12 because 11 has been leased out. Back on call switch 2, okay, call switch 1, same. For VLAN 30, current index is 12 because 11 has been leased out. Show IP. As you can see, that's the IP address over there. Now take notice of the DNS. I told you that on Fortinet firewall, we are using the Fortinet inbuilt DNS resolution protocol to resolve IP addresses. Now that's the best way. You wouldn't want to conflict your own DNS with FortiGate's DNS connecting to the internet. That's an inbuilt DNS. Good. So we are good to go. I think the last one will be good. So we are good to go. I think the last one will be in this PC. I'll turn it on for VLAN 30 and I'll open the console. So the console is up on my other screen. Let me bring it here. So definitely we have an IP address. So terminal. And before that, okay, so the terminal is up. So if config, it's a Linux device. So if config shows me we have 30.11 leased from the 30 VLAN or VLAN 30 database or DCP pool. So what's your favorite website? Let's go to youtube.com. That's my favorite website. I'm always on YouTube learning. youtube.com. And YouTube will load. So let's test connectivity from this PC to the outside world. Ping google.com. Let's try again. Okay, so now it's working. It was doing name resolution. So ping yahoo.com. So it can't resolve. Let's try again. It will. For the third time. Come on. Sometimes it's because you're in a virtual environment. It takes time to load. Oh, okay. So it has opened my gateway rather. Oh, I see. Okay, so let's try facebook.com. So let me try the ping again. facebook.com. Oh, that's resolved. Yes. Come on. This has to do with my internet provider. My network is very slow. Very slow. Let's try again. It has to work. I know it works. It can't resolve. It will. Okay, so as you can see, this one is trying to open Facebook. My internet is very slow. I accept that, but just a demonstration for you to see. Now you see that this PC over here comes all the way. Here's my design. So this is PC3 over here. is connecting to this switch, getting an IP address from this core switch, acting as the distribution layer, hitting up all the way to the core layer, which is the router over here, and all the way to the Ethernet. So I'll open over here and all the way to the Ethernet. So I'll open my FortiGate. I'll go to dashboard, status. I can feel my machine is very slow. Yeah, it's because I'm running a lot of simulations on it, but that shouldn't be the case. Everything will be fine. Takes a while to load, shouldn't be so, but let's give it some time. Okay, finally it has. Good. So now let's see something. The FortiGate firewall will take a log of every device in its network whatsoever. So I wanted to show you something. Okay, so users and devices. That's where I was particular about. So we have device inventory, of course. We have 10 because I was trying to so as you can see, I've been running simulations before this video. So as you can see, other devices. Now I see the storm, that's my PC with this IP address. And now we have PC 21 with this IP address in VLAN 20, VLAN 10, which is unidentified OS. So that's it. So basically, that's how you program your network using Python. There are a lot of ways to program your network, and there are several ways using Python automation or whatsoever. Thanks for watching this video, and the last thing that I'll do is do a backup of all my devices. So I'll go to the device tab, now add the rest. And I'll make it 4, 5, and then 6. For the sake of this purpose, or for this recording, I'll run the script directly in my terminal. So as you can see, it will execute the code, and then it will take a backup configuration from all the switches. Okay, good. So we have access switch 1, 2, 3. So it seems it was a problem connecting to okay, we have core 1 also. Do I see core 1? Let me refresh. Okay, we have core 1. Seems you couldn't connect to core switch 2. Yeah, so that's it. I mean, look at the time it took to execute this. That's the power of using automation. Thank you for watching this video, and subsequently I'll be uploading a video on network device auditing using Python automation. It's been a long video. Thanks for watching this video, and I'm so grateful. Bye bye.